Okay, huge correction on 748. Huge correction. My mistake on the analysis that you should not use a linear process, even though it makes sense. It's the wrong answer. Here's how you should do it. So you can see that when there's 24 units times 300, we get a specific yield of 2 times 600, 6,000, 7,200. And you can see that even though we're going down in units, or sorry, down in yield and up in units, you're still going to get a higher yield. You're still going to get a higher yield. So 25 times 295. So it's still going up. It will reach a point, though. It will reach a point as these go down. It won't balance out well enough with this small number. So when this hits small enough number, essentially it's going to go up and up and up and up and then down. It's going to be a parabola. And since clearly we're going up from 24, the peak is going to be somewhere after 24. Now you could take 50 just to show. So let's say 50. Let's take a number that's easy to do. 50 is 26 higher, which means this thing would be lowered by 5 times 26. It would come down to 170. If I multiply that by 50, suddenly, while my yield is still high, there's a good chance I'm coming down the other side. To prove this, take 51. So 51 times, open brackets, 300, minus 51 is 17 higher, no, 27 higher. So 27 times 5, 165. And you can see it's going down. 51 is 8, 4, 115. So that means 51 is 8, 4, 115. That means 50 is coming down somewhere over here. So there's some magical number. And again, this was around, this is whatever, 26, 300 minus 26 times 5 is, whatever it was. 5. It was 170. So this is 165. So clearly there's a magic number somewhere in between here where we get maximum amount of yield, because it's the number of processors times the average yield that gives us the total yield. So if you look at this, the processors are going up by 1 and the yield is going down by 5. Normally, if I was going to figure out my yield, I would take number of processors and multiply it by the average to get total qubits. Okay? Average qubits. To get total qubits. And our first number that they give us as processors is this. You can see the next one they give us is this. Well, we have to find a geometric way of expressing that. So what goes up? Well, 24 is going up by 1, 4 plus 1x. And each time 24 goes up by 1x, or an x, 300 is going down by 5x. There's my correction. So I had it incorrect before. Now we should rearrange this so my x's are in front. To get an idea of what the actual quadratic is. And technically you could probably factor that to figure it out, but we're going to use the way the derivative. So anyway, that's 5x squared plus 300x minus 5x squared, by the way, minus 120x plus 24 times 300. And actually the number's not going to matter, because when we take the derivative, it's going to disappear. We can see 300 minus 120 is 180. And so there, I made a mistake before when I described it, and probably because I didn't do a proper number for the number of processors. Number of processors was probably not x. It's probably like 24 plus x. So anyway, we're at there. We take the derivative. Set to 0. X is 18, but we've got to go back to the number of processors and realize in our formula, it's 24 plus X for the number of processors. So when we take that, 24 plus X, which is 18, we get 42 processors. Now, I don't know what I said in the exam. I actually think I did say 42. So it might be a different method. But this method I prefer because logically you can see as something goes up, something's going to go down, and it's going to create a parabola. You just have to figure out how much this other thing is going up for each time X is going down. And really, this is an expression of the Y that I had earlier. This is the linear, but what I didn't fail to do, I multiplied it by X, but it had to be X plus 24. So remember when my thing, I multiplied it by, I had the linear representation right here, which I might have gotten wrong. But I had the linear representation. I got that right, I think, minus 5x plus 300. But I had the number of processors incorrect. It had to be x plus 24, not x.